intelligence with a vision to spearhead technological evolution in the field of industrial lubrication reliability.
In years, we have strengthened our quality control and R&D section in such a way that our products are beating European standards now. Keeping the technological cost very low and effective, we could penetrate the international market, PSUs, oil and gas sector, and many more. Here we believe to deliver an intelligent solution, not just a machine.
We have three pillars in Minimac. The first one is a sales team, which is very well trained to make sure that all the technical requirements of the customers are understood in depth. The second one, which is MOMS, which stands for Minimac Operations and Maintenance Services. They are the ones who are responsible for making sure that the site support is given time. The third one being ASS, which is Aftermarket Sales and Service, who are responsible for making sure the installations and commissioning is done on time.
With new facility commissioning at Japan, we have increased our in-house production capacity by more than 300%.
Minimac implements EJCS very strictly, that is, aid job customer satisfaction.
Minimac believes in a prompt delivery within a lead time of 4 to 6 weeks because we understand the customer's requirement. As he ordered us, we have to deliver the goods within a stipulated time period.
Minimac systems have a strong mandate towards giving back to the society. For this, we have multiple programs and initiatives which are taken up by the CSR team at Minimac Systems. We carry out multiple tree plantation activities within our premises as well as across the neighborhood of our town. We have already benefited more than 500 girl child in the state of Jharkhand and Maharashtra by providing them better primary education. We strongly hire freshers and young enthusiasts who can work for the organization, get trained for further career plans. Minimac team welcomes the communities and individuals to come out and help us have a sustainable environment for our future by recreating the circular economy around us.
As you already know, Minimac has a global presence and is a multi-sectoral company, being available in front of our customers at the right time with the right product is quite challenging for us.
As a company, we are focusing on youth empowerment as our 40% of strength is between 21 to 26 years. Also, we are ensuring gender parity in all our recruitment drives. Every year, we are hiring fresh engineers and management trainees for employment and internships.
Ladies and gentlemen, distinguished guests and esteemed experts, a very good afternoon. A warm welcome to all of you to this highly anticipated panel discussion on a topic that has captured the attention of the world. The net zero race. Are we getting there? I am Chetna Sharma, Marketing Manager, Minimac Systems. Today, I am honored on behalf of Minimac Systems Private Limited to stand before you as the host of this webinar and to facilitate this crucial conversation on a subject that will shape the future of our planet. Today, we gathered here to delve into the concept of net zero and explore the myriad opportunities and challenges it presents. The notion of achieving net zero emissions has become an imperative in the fight against climate change. It represents a bold commitment to balance the amount of greenhouse gases emitted into the atmosphere with an equivalent amount removed, thus effectively neutralizing the impact of human activities on our climate. As the urgency of the climate crisis becomes increasingly evident, net zero has emerged as a rallying call for nations, industries, and communities around the globe. It is a powerful vision that combines ambitious targets with innovative solutions to create a sustainable and resilient future for generations to come. Today, we are privileged to have a distinguished panel of experts who bring with them a wealth of knowledge and expertise from various sectors. Introducing our four distinguished panelists. Mr. Calfon, a machinery lubrication expert with over 35 years of experience. As the General Manager for Middle East and Africa at Fluidtech, he drives the adoption of green treatment technologies for hydraulic oil, optimizing operations and minimizing downtime. Certified lubrication specialist with a master's degree in international business from Institute Commercial de Nancy, he is the trusted authority in the field. Dr. Debashish Mukherjee, a seasoned professional with over 4 decades of experience, holding an impressive academic background with an MSc, PhD, and a postdoctorate degree from IIT Kharagpur. He has excelled in managerial roles at Indian Oxygen and BOC India Limited and Tractors India Private Limited. As a consultant, he brought valuable insights to Castrol India and collaborated with a Caterpillar dealership, making notable contributions through his expertise in engineering and management. Meet Mr. Rafi Britton, a mechanical engineer with extensive experience in the oil industry for over 12 years. As the host of the popular Lubrication Explained YouTube channel, he simplifies complex concepts. Currently working as a technical consultant, Rafi assists industrial companies with lubrication challenges and helps lubrication manufacturers effectively communicate product benefits. With a background in aerospace engineering and science from the University of New South Wales, Australia, he brings a unique blend of technical expertise and communication skills to his role. Meet Mr. Kedar Gore, our final panelist, an accomplished engineer and MBA with a track record of over 20 years, driving strategy and execution in various industries. From lubricants to MHE, SaaS to e-learning and e-commerce, he excels in sales, marketing, and digitalization. Kedar's expertise lies in leading teams, implementing pricing strategies, and enhancing customer satisfaction, all while achieving remarkable business growth. When not working, he indulges in fitness pursuits, immersing himself in nature and embarking on outdoor adventures. The flow of the webinar will be a panel discussion among our experts on the questions put forward to them by the host, followed by a AMA Ask Me Anything session where we would take the questions put up by the audience. So, before we proceed, I would like to remind you all to drop your questions and queries in the Q&A box, not in the chat box, as there is a chance of missing some questions in the chat box. As we navigate this evening's discussion, let us seize the opportunity to learn from the experiences and perspectives of our esteemed panelists. So let's begin. My first question to the panelists: What does the concept of net zero mean in the context of climate change, and what strategies can be implemented to achieve it on a global scale? Over to you, sir. I would request the panelists to put forward their views.
Yeah, I think maybe everyone's on mute or something so far. But I mean, net zero fundamentally is not a incredibly difficult concept for everyone to understand in terms of it's literally as it says on the packet, right? It's net zero carbon emissions. So at the moment, we're putting an annual amount of carbon emissions into the air, whether that's through combustion of fuels, release of gases into the atmosphere. Say, for example, in natural gas processing, there's a lot of methane leakage. So there are a variety of different sources. And at some stage, in order to have minimal impact on the planet, we're going to have to use a bunch of strategies to get ourselves to net zero. Now, the reason why we say net zero rather than just zero emissions is because there are a variety of industries for which it is going to be exceedingly difficult to get to zero emissions. So if you think in particular the marine and aviation sector, we don't have credible alternatives at the moment for fossil-based fuels. So in order to get to zero net impact on the planet, we've got to derive strategies that can put some carbon back into the ground in order to offset the emissions from those industries. Now, obviously, there's a range of different, strategies that have been come up with. So some involve kind of fixing carbon into the ground by way of kind of bioagriculture. And then there are others which are looking at direct CO2 reclamation and injection back into the ground. And we'll probably get into some of the challenges involved with that. In my country, in Australia, we have the largest carbon capture and storage project in the world. And it's part of the Gorgon-Jansz project. That was actually built so the Gorgon-Jansz project is one of the biggest LNG projects in the world. And the government stipulated that in order for the project approval, they had to be able to capture and store, I think it was about 16% of the total carbon produced as a result of that project. That project, which is currently operated by Chevron, has never been able to achieve its carbon capture goals. So, and this is, one of the most advanced organizations in the world attempting what has been advertised as a relatively simple exercise, and they've never been able to hit a technical target. So I think that sort of shows a little bit the challenge really of getting to net zero fully.
Yeah, I think Rafael very well said. Just adding points there. So as you rightly mentioned, net zero is basically negating the amount of GHGs which are primarily produced by human activity. While certain level of GHG is important for to maintain the temperature of the earth and for life to survive, too much amount of GHG is obviously very harmful. GHG means greenhouse gases. And there are only two ways by which you can negate, the net zero, or achieve net zero, is either by reducing emissions, which, as you rightly mentioned, is not really possible for some of the industries. So one is either you reduce emissions or you implement methods of absorbing carbon dioxide from the atmosphere, right? So that's, I think, only the two ways in which you can, ideally, achieve net zero. While there are, a lot of technologies available, there are TPO applications available to, reduce your emissions. There are also, on the other hand, technologies and, attempts being made at, putting more carbon, absorbing more carbon from the atmosphere, primarily carbon dioxide and other gases, right? I think there are a lot of strategies at corporate levels. But I would like to give a small example of how you can actually reduce carbon emissions in your home. I have a booklet which is released by the Ministry of Environment and Forests and Climate Change, Government of India. It actually called itself Low Carbon Lifestyles. Okay, small booklet. Just a small example of how you can actually reduce carbon dioxide, carbon footprint at home is switch off all appliances at the plug point and not with a remote. Do you know how much energy you can save every year, or rather how much CO2 you can save every year? 135 kg. right? And 1 ton of, so that's the amount of carbon dioxide you can save by just plugging off your appliances at the plug points and not just by the remote. So for example,
135
television, 135 kg.
135 kg per family or
per year, per family, per household.
Per year per family.
Yeah,
that's huge. That's huge.
That's huge, right? I mean, just for if you are not watching your TV, don't switch off from the remote. Just walk over to the TV and just switch off the main plug. That's it.
Yeah.
Okay. So this is a huge study, and so I mean, just a small example of how you can achieve net zero even at home while you're sitting. I mean, some of us leave the water taps open while we are shaving or brushing. I mean, do you know how much energy is spent in getting the water up through a pump? Okay, using electricity. It's not just wastage of water, but also wastage of electricity, which ultimately is produced, at least as far as the world knows, 70% of the electricity in the world is produced by non-renewable resources, which is by burning fossil fuels or coal, right? Just imagine, I mean, if each one of us starts saving a small amount of, energy, how much it will, it will eventually turn out to be. Although the largest amount of energy today generated or the CO2 emission generated is from the industrial sector, this is primarily energy, transportation, agricultural activity, and livestock farming. Yeah, but we in our own small, we're also responsible for, I think, reducing the carbon emissions. Yeah.
There is one more basic practice that you could mention to the public people that when you are switching on the AC or AC machine, split AC, Windows AC, keep it always at 24 or above 20. That will reduce huge amounts of power.
So there's a lot of details about what each of us can do, and it's always the same way of looking at things, which is unavoidable, which is to think globally and act locally, what you've been discussed here. If you allow me, I would like to put a little bit of context into this, because I've been in energy for 35 years, and I think in energy discussion, one thing that makes the discussion not as easy as it may be is that people have no grasp of the dimensions involved. So energy is a very hard industry. Extracting and producing this energy is extremely difficult, more than the general public realizes. And second of all, the quantities of energies that we need is enormous. Another matter is that the general public has no grasp for how big, difficult, and very big. If we explain to someone how many carriages of railway we need to bring to a major baseload coal power station every day for the production of power by that coal power station, they would be shocked. They would be shocked the quantity of coal that needs to go in to produce the electricity. And I want to add another dimension to this discussion, which is the matter of stability, because we're in a world of between 7 and 8 billion people. The middle class is growing very fast, in particular in countries, emerging countries like China and India, even in Africa, and now the biggest middle. But we're not out of the woods yet. We still have at least 1 billion people living in abject poverty, and for sure one of our objectives, we're looking at the planet, we have a few things to balance, and one of the things we need to balance is that there's hundreds of millions of people, probably 1 billion people, from abject poverty, and this is, I think, very sensitive topic for India in particular, but it's worldwide. When we look at these people, one thing they lack is clearly cheap, plentiful energy. So this is where we'll find people using for fuel wood or dung or whatever they can find, because they lack cheap, reliable, and plentiful energy. So in this is, I think, something we should lose track of, is that whatever solutions we look into, we still need to bring this reliability, this affordability, and this abundance to a very large number of people on the planet. And so anything that we do to make energy less abundant, I mean more rare, or if we do or more costly, or less reliable, and I know that we are trying to bring online a lot of production methods which are intermittent and random, so basically less reliable. When we do these things, we need to balance it with the human need to extract so many people out of poverty still. Now, also as part of context, I would like to recommend at least one book to read for everyone to understand by a scholar called Václav Smil, S-M-I-L, Václav Smil, and the book is called How Does the World Really Work? Because we need to understand how things work before we can change it. So this book is a bit famous, and it highlights the things that we need, that we cannot do without, mentioning fertilizer, steel, cement, and I think the fourth one, which is the plastic material. These are things we need, and that are very energy dense or fossil fuel dense. And so I think it's a good book to have as a first background. So this is a bit of a step back, eagle-eye view of the matter. Then, because my company Fluidtech that I represent here is focusing on lubrication, and so the way that we define ourselves, our contribution to this overall matter is something that we call Fill for Life. So this is not for households, this is mostly for industry. One thing we noticed because of our 30-year experience in matters of measuring, correcting and cleaning, and then making life of products much longer. One thing that we noticed is actually in this particular field of lubricants and hydraulic fluids, these products most of the time get changed, get dumped, discarded much too often. So by applying a few technical steps and chemical steps, this is an example where we can really change the world, at least in one field, by making the fluid much longer life, which means that they will be changed a lot frequently. And then once we do that, we have a rigorous certified life cycle assessment, by which we mean cradle to grave. We can come up with a serious CO2 equivalent emission spared if we don't discard the product and we don't dump it and we don't treat it as waste, whereas it could still have a long life. So this requires, so this is something that may be a little bit more specific, but you were talking about the approach from a household standpoint, and so we have also this approach from an industry standpoint. And of course, every machine has lube, and many machines have hydraulic fluid. So this is also from our standpoint something that we can bring a contribution. And on top of that, what's really a nice thing about that is that in this particular case, the CO2 equivalent reduction will be done also by saving costs. Not an option that will increase the cost of the overall production. On the contrary, so this is I think an approach that is very promising because of that, because we don't sacrifice anybody's standards of living. Quite the opposite. We can hold the efficiency and total cost of the system. So this was my initial few remarks that I wanted to make to get our discussion on net zero to gear. Thank you.
Sure. So I understand, and thank you a lot for the book recommendation, Mr. Kalfin. And as per my understanding, there are a lot of social and behavioral changes which will have to be done at the grassroots level to support the global goal of net zero emissions. right? So my second question would be, what is the concept of extended producer responsibility and how does it contribute to sustainable waste management and environmental conservation, please excuse me?
Yeah, I'm not sure how this question is meant, but yes, one thing I would say about that is where do you place the responsibility on reducing greenhouse gas emissions or greenhouse gas equivalent emissions. And the reason why I mentioned that is that in Western Europe, where I am, some oil and gas companies are getting sued for the overall CO2 emissions of their production of the products that they deliver to customers. So I don't have an answer for this, but maybe a way to raise your question, who should be on point to cut emission? Is it the producer of the product, or is it the user of the product, or is it the end customer? So this is something we need to give some thought to and reflect who in the chain has the particular responsibility for cutting each kilo or each ton of greenhouse gas emission. I don't know if that's how you meant the question.
Hey, Rafa, you want to go ahead?
I was just going to say, my understanding is that the extended producer responsibility there is a formal kind of OECD definition of it, which is basically just to take, whatever you're producing as a company, and if you're financially benefiting from the production of that, whatever product it is, and taking responsibility for the entire life cycle of that product in terms of its carbon emissions. So it's not just at the production stage, but it's also at the usage stage. So obviously we can talk about industrial applications of it, but often when I talk about this extended producer responsibility, people wonder why it should be that the manufacturer needs to take responsibility for that. And when kind of explaining why, I usually try to give an analogy. Let's say, for example, with consumer electronics. One of the reasons why, let's say, for example, we've all probably experienced this. In the early days of laptops, if you can cast your mind back to like 10, 15 years ago, you used to buy a laptop. And if, let's say, for example, the hard drive died or the motherboard died, most of us here kind of have an engineering background. You could probably buy spare parts, open up the laptop, fix it yourself. All right, so that's an example of extending the life of the laptop and avoiding a whole bunch of waste going to landfill. Well, try doing that with a modern laptop. It's actually very difficult to do because the manufacturers have made it difficult. A lot of the components are soldered to the motherboard or they're glued down with adhesives. Now, the likes of Apple and Samsung will say that they've done this for the sake of user experience, right? It's a better user experience. However, what that affects is the downstream waste management, because it's almost impossible to recycle some of these products. And it means that people are more likely to throw them out because, for example, the hard drive is not replaceable. It's not upgradable. So a lot of these choices are baked in at the manufacturing stage. And so because a lot of these decisions, a lot of these design decisions are governing how the product can be disposed of down the line, it means that we need to shift the responsibility onto the manufacturer because they're making those upfront design decisions.
Yeah, I think it's a good example, Rafi. Just like to, to explain concept of EPR, which as you rightly mentioned is extended producer responsibility. I think the audience here needs to understand the concept of linear economy versus circular economy. And EPR is based on the concept of circular economy, right? What's the difference? So basically, if you look at linear economy, as you were mentioning, a manufacturer takes raw materials from the earth, manufactures a product, sells it to a distributor who sells it to a consumer. The moment the product reaches the consumer after the warranty, the manufacturer has no responsibility of the product. He doesn't know where the product ends up after his life cycle is completed, right? Probably ends up in a scrapyard, probably ends up in a landfill, in a water dump, or gets burned into the atmosphere. You never know what happens, right? A circular economy is exactly the opposite. It talks about, being responsible for, reuse and recycling or refurbishing or regeneration of the, product. So basically you use and you again recycle the product back into a finished product, right? So it works in a way that we are essentially and as I mentioned, reducing, reusing, and recycling products. So whenever, for example, let's say our case of oil, typically what happens, a lubricant is made from virgin base oil, which is extracted from crude oil, right? But there's a technology, if you can get the used oil back and make a re-refined base oil, which is an RRV as it's normally called, it can produce the same quality of a finished lubricant. Unfortunately, today in India, at least, or in most parts of the world, except probably Europe, the used oil still lands up, in a burning, it gets burnt as a furnace oil, or gets into a construction material, basically gets into hazardous end uses, on which the manufacturer or the brand owner has no control. Okay, so EPR is essentially nothing but a government policy or legislation that places a significant responsibility on the manufacturers, producers, importers, brand owners of a product to bring back the end of life cycle products as recycled feedstock or raw materials, instead of using new or virgin raw materials which are sourced from non-renewable resources, right? As we speak, so as I mentioned, it's a legislation which many European countries have implemented quite a while back. It has now been implemented in India for 5 sectors, and it's started with plastic waste way back in 2016. Last year, 2 more ZPR were implemented in battery and rubber tire waste. This year, 2 EPRs have been implemented, one in e-waste, and just 2 weeks back, one in used oil. And my company kind of specializes in EPR, compliance and EPR registrations and basically EPR consultation. So, and just a summary of the EPR, and totally 11 sectors, at least in India, I have identified where EPRs will be rolled out by the end of next year. Okay, and this essentially provides a lot of emphasis on compliance. It becomes a law, right? So you actually can't get away with it. So every company or producer of any particular product has to produce what they call a recycler certificate or an EPR certificate, okay, for an X percentage of goods that you are manufacturing in a particular year. So for example, if I have sold X amount of oil in a particular year, lubricant oil, 2 years hence, I have to ensure that 10% of this, the oil that I sell, has been purchased through a re-refining process, for example. Then that 10% goes up to 20, 30, 40, 50, 60, like that. Similarly, in case of e-waste, similarly in case of plastic waste, batteries and tires. So everywhere a producer or a manufacturer or an importer is going to be compelled by law to bring back recycled raw material into their manufacturing processes, and not just go and, bring back, get renewable resources in their non-renewable resources in their virgin form. As I mentioned, the EPR has a few salient features. Firstly, they clearly define the term producer, which includes all manufacturers, brand owners, importers, sellers. So essentially nobody can get away from in the ecosystem except the consumer, in a way, right? Except the consumer, everybody has a responsibility and an ownership and an obligation and a legal, compliance to be able to do fulfill those obligations. Second is, it has got predetermined targets for each producer in terms of using recycled material. So as I mentioned, starting with 10%, 20, 30, 40, 50, 60, it kind of gradually increases every year as the collection of the, the used product goes up, okay, or the waste product goes up. Thirdly, there is an online process. There is a portal which is, under the control of the Central Pollution Control Board, where you have to go and register yourself. Only registered entities will be allowed to trade. Anybody who is not registered, if it trades, there will be a legal, issue to that, right? So you will have to declare your e-waste online. You will have a certificate will be generated online, and you have to buy a certificate online. So everything is very transparent, very online. There are audits which happen on that. Okay, and lastly, there is, because it's a law, there is enforcement. There is legal obligation. You can be pulled up, you can be fined. There are provisions for fining in the law, and the government can fine you if you are not following these rules. So EPR essentially is a set of rules and regulations which are legally binding and enforceable, and we're already seeing shoots of gray shoots of what should I say, compliance, especially in the plastic industry, because it was the first EPR which came in 2016. And now we are 4 EPRs which have come in the last 2 years. So But there are implementation challenges because I'll just finish myself. There are implementation challenges. It is not as easy as it seems, because in a country like India or even a country like Africa, which Julia mentioned, which are very low on the Human Development Index, there is a lot of poverty there. There is a lot of what should I say, informal sector already dealing in collecting these waste, and it's a completely low level on the Human Development Index kind of people. So rack pickers, mechanics, okay, these kind of people are actually involved in this kind of trade. So there is a lot of awareness, a lot of training. You actually have to work at NGO level, at self-help group level to be able to generate that. So a circular economy actually exists, but it's not in the formal sector. It's in the informal sector. You actually have to get it to the formal sector. Okay, and the biggest problem you need to solve is getting the collection sorted and getting the collection in the formal sector, because technology problems are solvable. I can put up a plastic recycling plant. I can put up an RRBO plant. Okay, I can put up a e-waste recycling plant. That is not a problem. Collection and getting it into the formal system is a problem, which in a way the EPRs are trying to solve. Okay, so I think we are pretty hopeful with what we are seeing, that EPRs, if implemented properly, I think will be a key driver in driving circularity, and obviously reducing the burden on virgin natural resources. Because as a small example, we always quote this example from the oil industry, and since all of us from oil, I think we will understand this example of what is the kind of energy that is spent. So if you want to manufacture RRBO from used oil, okay, versus manufacturing virgin base oil from crude oil, the energy required is one third. Okay, if you want to have 100 liters of if you want to produce 70 liters of re-refined base oil, you need 100 liters of used oil. 70% is the is the ratio. But to have 70 liters of virgin base oil, you have to distill 7,000 liters of crude oil. Can you imagine because it's a fractional distillation process, right? So that's the kind of comparison you're talking about, right? Imagine the kind of benefits a circular economy or an EPR will bring if properly formulated and properly implemented, especially in countries which, as mentioned earlier, like countries like India and basically even China or even in Africa. Yeah, so sorry for that long speech. I must have been in this long speech alert probably, but yeah, that's about it.
That was great, Kedar. I was just going to say maybe one other example. So how we do it in Australia, it's a slightly different framework, but the way that we do it here is that the government imposes a tariff. It's a flat tariff on all lubricant marketers. So if you want to sell 1 litre of oil, you pay 14.5 cents to the government. Flat rate. That 14.5 cents is not just taken as tax revenue by the government, but it's actually paid out to re-refining companies who take the waste and then refine it back into group 2 or group 3 base oils. So it's doing two things, right? It's imposing a tax on people who are financially benefiting from the sale, and then it is also then being given as a financial incentive for companies to invest in re-refining plants. And so that's really helped the re-refining industry in Australia, because 10 years ago it really didn't exist until these financial incentives were put in place.
I have a question regarding this rate then. If you find a way that you don't need to change the oil, so you don't need to re-refine them, which is overall better, are you disincentivizing this by this system that you just described?
Yeah, so no, because at this stage, the concept of like the EPR process is to put the cost on the producer, right? So the marketer, and so that in what you're describing is a benefit which is produced by the user, the end user of the lubricant. And at the moment, there's no formal way to reward that kind of behavior outside of the fact that they're using less lubricant, and so therefore it's going to cost them a lot less. Right? Now, indirectly, they'll financially benefit because there is a financial cost to collecting waste oil, right? So the less waste oil you produce, then the less it's going to cost you in terms of disposal as well. So there's obviously benefits, but there's no formal governmental way that the government rewards that kind of behavior.
And I think that's another way of asking the question of the producer responsibility, because the producer will never be very tempted to produce less. So if we find a way where we need to consume a lot less of the product, for instance, lubricants and hydraulic fluid, then we are unlikely to achieve that from the producer standpoint. We prefer to produce more. Basically,
yeah, no, I totally agree.
Exactly, that's exactly a point that I come across often. A lot of the loops and reconditioning, re-refining, that, and that's where the incentives are. That's where the policies are. But actually, one step upstream of going to that extent, we can keep the keep the fluid, keep the lubricant, keep the hydraulic fluid in the machine, and doing fine work and much longer. So we don't even need to drain them and re-refine them and reuse them. We can just keep using them where they are. So I had a success with an industrial company that way, and the question that they asked me is, how can we recycle, re-refine our oils and then reuse them? And I told them, you don't need to do that. We'll help you in keeping this oil in top condition in this machine. You won't even need to, and recycle it and recondition it and re-refine it. Just keep it going.
I mean, you're right. MQLs, that is minimum quantity lubrication, long life lubricants or long ODI oils, as we call them, or even good conditioning monitoring will certainly, basically is as efficient as as a refining, in my opinion, because you reduce the amount of waste that you are generating in the first place. I think that's what we call in circular economy, right? Reduce, reuse, and recycle. So first step is reduce, second is reuse, third is recycle, right? I mean, and EPR's focus on recycling. Reduction is in obviously hands of technologists like us, and reusing is in the hands of the consumers, right? I mean, so I think, and everybody plays their part. I'm pretty sure.
Yes, we can.
Yeah, I think we should be able to achieve our.
Yeah, we can keep using instead of reuse. It's partly how you formulate the fluid to be a very long life fluid from day one, but it's also with condition monitoring and with corrective action, purification, contamination, etc.
Absolutely.
You get to a point where you only need to, I say only, but that's where a bit of science is. You need to rebalance the formulation, the additization of the fluid, which you can do without shutdown of the equipment, and double the life of the fluid, be it industrial oil or hydraulic fluid, during production, not disrupting the equipment running and the equipment production at all. We can rebalance the formulation during the in-service life of the fluid.
Totally, sir. So, Kedar sir, do you have anything to add on to this question?
No, I think unless I'm answering some questions on chat one-to-one. So.
All right.
Yeah,
Thanks a lot for that. So my third question to my panelist is, what are the differences between Scope 1, Scope 2 and Scope 3 emissions in the context of corporate greenhouse gas accounting? And how do organizations measure and manage each of these emission scopes to reduce their environmental impact? Please allow me to repeat the question. What are the differences between Scope 1, Scope 2 and Scope 3 emissions in the context of corporate greenhouse gas accounting? And how do organizations measure and manage each of these emission scopes to reduce their environmental impact?
Cool. I mean, I can start here if you want. I always get these ones mixed up, to be honest. So I would encourage everyone to Google this every time you want to look up the differences between scope 1, 2, and 3. But broadly speaking, my understanding of it at least, and I think this is pretty accurate, is scope 1 is what we would call direct emissions associated with a company. So if you have a company and you house your people in a building, you've got people driving company vehicles around, you have an industrial site, all of the emissions which are associated with those facilities are what we would call scope 1 emissions, right? You've got scope 2, which might be what we call indirect emissions, which are associated with those activities. So let's say, for example, you have an industrial site and you are purchasing electricity. So an example of scope 2 emissions would be the carbon emissions associated with the production of that electricity. So it's not completely direct in the sense that you are not emitting, but you are also kind of responsible for the choices that have been made about those emissions. Because, say, for example, you could choose as a business to purchase electricity from renewable sources, right? That kind of thing is now starting to become more and more available. And then scope 3 is kind of all of the upstream and downstream indirect emissions associated with everything else in your value chain. So the downstream activities would be, as an example, if you produce a product, right? Let's say it's consumer electronic. It's all the carbon emissions associated with the use, transport, and eventually the disposal of that product. In the context of the oil industry, let's say you produce fuel, right? Scope 3 emissions would be the burning of that fuel and the transportation, the carbon emissions associated with transportation of that fuel. Maybe it has to get shipped overseas or something like that. Then you've got upstream scope 3 emissions, which would be something like the, let's say, for example, again, if I'm producing consumer electronics like a company like Apple, all of the carbon emissions that goes into producing the iPhone, right? So the mining of the materials, the transportation of those materials to manufacturing facilities and all that kind of stuff. So, using this framework, scope 1, scope 2, scope 3, helps us kind of broaden the definition of emissions that a company is responsible for. Now, wrapped up in that, I think there's also kind of a moral argument, right? So some people might say, morally, why should companies be responsible for the way that their products are used, right? So let's say, for example, again, you are Apple. The energy associated with the use of one of their laptops is really dependent on the user. So why should Apple be responsible for that? And the flip side to that is that increasingly the power to make a lot of these changes rests with those companies. So if you look at Apple and you compare their scope 1, 2, and 3 emissions, I think it's something like 85% of the total emissions associated with that company are scope 3, right? Now, Apple is obviously not compared to Saudi Aramco, but on the American Stock Exchange is the biggest and most powerful company in the world. So if anyone has the resources to be able to make a dent in those emissions, it's Apple rather than the end user, right? End users, we can only do so much, right? Now, it's still all our responsibility, but we can only do so much. A powerful company with the resources that Apple has really has an opportunity to affect those scope 3 emissions. And that's one of the reasons why it's good business sense for them to start taking care of those scope 3 emissions.
Certainly. If I could have some views from Mr. Mukherjee as well, or Mr. Calfon.
I have nothing to add to what Ray just said. I think with Wave, and I don't have anything particular to add to what he said. I was listening very carefully.
Okay. Mr. Mukherjee, if you would like to enlighten us with something on this topic.
I can touch upon a few basic points of how to...
Please.
Regarding this circular economy and carbon emission. But the industry, oil industry, I was in oil industry. the oil life can be extended as our panelists are saying by proper storage, handling, and dispensing of all the fluids, and the oil then interval can be extended. And at the same time, the machine life can also be extended by proper condition monitoring and proper failure analysis. The machine life can be extended to 100, because when the machine life is extended, the steel emission, steel consumption can be reduced. Steel, cement, plastic, aluminium are the largest carbon emitters in the world. If you can reduce the steel emission, you can recycle the steel. You can do the failure mode and effect analysis. You can do the root cause failure analysis. You can increase the life of the machine. You can increase the life of the component. See, if you can increase the life of the engine or life of transmission or life of hydraulic by 20% or 30% to proper condition monitoring, to best practices, then the steel manufacturing will be reduced. Steel generation will be reduced. That means carbon emission will be reduced. 1 ton of steel produces 1.89 ton of carbon. That's a huge amount. Similarly, 1 ton of cement produces about 1.75 ton of carbon dioxide. So, what I was saying is, proper best practices are no longer an option. It's a compliance. People cannot work like a roadside garage mechanic in any workshop, in any manufacturing area, in any site. Proper practices must be implemented, and for that, cultural transformation is required. Cultural transformation from top to down. Leaders and top management must be aware of these best practices. What benefits the company is going to get? Your waste will be reduced. Your machine life will be increased. Your oil life will be increased. That's all I want to say. I mean, these are some of the basic points by which we can reduce the carbon emission. We can reduce the carbon dioxide emission. Even I am pouring the oil in the ground. There is no proper storage of the waste oil. The oil is mixing with the water. Those best practices must be implemented. Method must be properly structured. Road mapping must be there, because India has to be carbon neutral, net zero emission by 2070. Whereas America and other areas are 2050, China and Russia are in 2060, India is coming on 2070. And there is another way, is this plantation, sufficient plantation. But land is not available. Only 1/3 of the land is available in the country. So 1/3 of the land will be covered under forest. That is one example. But then in future, what will happen? The steel companies, the aluminum companies, their process modification will be there. These are very energy intensive process. A lot of carbon is emitted, very energy intensive. New processes will be coming, modified processes will be coming. So then carbon emission will be reduced. And then we are not talking about waste. Methane. 1 kg of methane is equivalent to 21 kg of carbon dioxide equivalent. It's a huge waste. It's a huge carbon emitter. So all these things are gradually they are coming. Gradually the processes will be standardized. Much better processes will come. Process modifications will come. That's all for me at the moment. Thank you.
Certainly. Kedar sir, you had some views on this topic. You were saying something.
No, I wasn't saying anything. I think Mr. Mukherjee covered a lot of points which were anyway on my mind. Yeah.
It's a challenging, and it's a huge complex activity, Kedar. Huge complex activity throughout the globe, and at least in our country also.
It is a challenge, and I mean, it will obviously increase costs for certain companies. And I think what Rafi was mentioning was the bigger companies can absorb it, but what about the smaller and the micro enterprises?
Yeah.
Whether the cost associated with becoming carbon neutral or reducing carbon emissions or going green, there are costs associated, right? I mean, to move from a grid electric supply to putting up a solar thing on your rooftop of your shed, it's a cost, right? An upfront cost of 25-30 lakhs in India for a small MSME. Where do you get that money from? What's the return on investment? So I mean, these are small things, but important things, you know. So at the end of the day, you need incentives, you need, awareness, you need good governance, you need the proper legal mechanisms. And that's how you see, I think, for example, the way, I mean, you see EV, I mean, a lot of people talk about EV. The reason why EV is going in India in two-wheeler is because of incentives right now. FAME2 is giving you 15,000 rupees discount as an incentive to the manufacturer if you sell a two-wheeler, okay, in India. The moment that discount goes off, you don't know what is going to happen to the sale of two-wheelers, right? I mean, because today they are on par with your conventional IC engine bikes because of the incentive. So, and a lot of things kind of come into play, you know, to make this possible. It is not just this or that. It is, I think, everything playing together in a coordinated manner. Yes.
By the
by the
way, I was hearing some of the American personality was saying that they are trying to put the charging stations for the electrical vehicles more efficient. Means 40% time reduction will be there, 50% time reduction will be there in each charging station. So if the charging time, there is significant time reduction in charging the electrical vehicles. Then there will be less carbon.
It's a bit of a digression, but as far as electric vehicles are concerned, nobody addresses the elephant in the room. You might be reducing pollution in cities, but you would require more electricity, and 70% of electricity is through fossilized resources right now. So, I mean, what's the impact on carbon emissions? I mean, somewhere some plant is going to churn out more electricity, right? And going to use more fossil fuels, unless the answer to EV is renewable generation of electricity. Okay, I'm not very sure how the EV thing is going to solve the problem. It may depollute the cities, but somewhere in the hinterland, there is a, as I said, there is a power plant, thermal power plant, which is generating electricity for EVs. That's going to use more coal. That's going to use more natural gas, right? So
I think the argument with the EVs is that the EVs have the opportunity to improve over time. So let's say, for example, you know, if you have an internal combustion engine powered car, it's, let's say miles per gallon, right? So its fuel burn per kilometer driven is basically fixed at the point of manufacture. You can play a little bit with, the timing and fuel injection and things like that to make it a little bit more efficient. But functionally, for the life of that vehicle, its miles per gallon is fixed. Whereas with EVs, if the grid is able to slowly transition to renewables over time, then the amount of carbon expended per kilometer can reduce over the course of the vehicle. That's kind of the main advantage, but it does rely on the grid transitioning at some stage.
Absolutely.
Yeah, maybe just one other comment on the Scope 1, Scope 2, Scope 3 discussion, because there is a bit of a challenge in terms of calculating the emissions. We really need sort of like robust frameworks around this. And just specific to the oil industry, something that's maybe a little bit relevant to people. For the lubricants industry, the API is actually in the middle of drafting a document to codify and formalize the calculation of carbon emissions as it relates to the production, manufacture, and use of lubricants over the life cycle. So that at the moment is in its draft form. So I've had a sneak peek at what the draft looks like, but it's a very robust framework for making sure that it's standardized across the industry. And that's really going to help, because once we have the capacity to calculate all the carbon that goes into it, then we can look for opportunities to reduce.
That's a great point, because one of the questions that got asked of us when we were discussing, when we had the EPR conference a couple of weeks back here in Mumbai, was the same thing. Are carbon credits available for, used oil anywhere in the world? But we didn't come across, anybody who, any country or any entity which has actually calculated the LCA for oil, lube oil basically, right? From the crude oil to the fractional distillation to actual conversion and usage. So yeah, thanks so much.
We have done that. Huh? We have come up with a certified calculator.
Okay.
And our scientific backing for this is a professor in TU Delft. So TU Delft is the leading technical university of Netherlands.
Okay.
There's a professor there who's a leading authority on this matter.
Okay.
And so we took a young, bright person who spent months with us, working hand in hand with his professor.
Okay.
And so we have come up with the best possible at this stage quality CO2e equivalent emission calculator for lubricating oils and for the solutions that we offer for lubricating oil. So this is one step down the way. I have no doubt whatsoever that this will keep being refined and improved. But we have this already. So this is something. If someone is interested in CO2e emissions on the lubricating oil side, this is something. This is a basis that we can already start working on and working with.
Perfect. Perfect. I think.
Do any of these panelists have any hydraulic fluid index data? Hydraulic fluid index is the ratio of the total lubricant usage annually divided by the volume in terms of number of feet, number of machines. Are you clear? Hydraulic fluid index. Hydraulic fluid index is the ratio of the total annual lubricant bought, purchased, divided by the volume actually used. Volume of the machines. Volume of the machines in the site. This is the global benchmark. Now the global ratio is 3:1. That means you are purchasing 3 times more oil than what is required in the number of machines, machine volume, hydraulic or transmission or whatever it is. Actual global benchmark should be 1:1. Just imagine how many liters of oil we are wasting annually in terms of leakage, in terms of oil misuse, in terms of bad storage, handling and dispensing. That is another area where a lot of carbon emission can be reduced. Practices, good practices. Yeah?
Yes. I agree.
Yeah,
Okay. Thank you for your views, sir. I would like to mention here that Mr. Calhoun had to drop because of some emergency.
No, that is something to say. You are just nodding. That's what I said.
No, all good.
Okay.
I am fine.
Yeah, so Mr. Calhoun had to drop due to some emergency. So I have a question that apart from the cost, what are the challenges actually that the organizations faced when measuring and managing scope 3 emissions particularly, except from the cost?
I think a lot of it's got to do with the uncertainty, right? So, with scope 3 emissions, you're having to account for the use of your product by end users. So let's take the example of lubricants. Let's say you're taking the perspective of a lubricant manufacturer.
Mm-hmm.
And you're responsible for how that lubricant is used ultimately. Now, you basically relinquish control of that lubricant once it leaves your gate. And this is the difference between cradle to gate and cradle to grave emissions calculations, right? So when it goes to, let's say, for example, it's a mining company, it's an oil and gas company, power generation, whatever it is, they use the lubricant. And then let's say, for example, they're making a choice about disposal. If they incinerate it versus they send it to a base oil recycler, the amount of emissions involved in each of those two steps is remarkably different. So how do you account for that as the lubricant manufacturer? Right. So that's a very difficult and complex problem to get over because you don't really have control over that. So even measuring that and quantifying that is difficult unless there is some kind of government framework which requires the end users to report how they're disposing of their lubricants in the end. So this API document that I talked about, which has been drafted, does actually give some guidelines on how to calculate it. And it basically says that if you have data available, then use the highest quality data available to make estimations, right, of the carbon emissions associated with those activities. But if there is no data available, then you must take the most conservative approach, which is basically to assume that the lubricant has been incinerated, whether that's in an internal combustion engine kind of similar to the way like a two-stroke oil would be burnt, or that it was sent for incineration as part of disposal. Now, the Fluidtech guys, I know, and Guillaume probably would have talked about this if he didn't have to step away, but I think, one of the things that they looked at was in their cradle-to-grave assessment is that the incineration of the lubricant makes up more carbon emissions than every other stage of its life cycle put together. So as an end user, the best decision that you can make for the environment is to divert your waste oil streams to a recycling plant versus to an incineration plant. The second best thing that you can do is to do all these, asset management and maintenance techniques that we've been talking about to extend the life of your oil as much as possible so you can delay that incineration for as long as possible. So that's kind of the takeaways that I put to you there.
All right. Thank you. Thank you so much.
How many times will you recycle?
How many was that the question? How many times can you recycle? I mean, it's mostly dependent. Sorry, it's mostly dependent on the type of fluid that's being recycled, right? So, as an example, engine oils are much more difficult to recycle than are turbine compressor oils, and that's largely to do with the level of additization, right? So, the more heavily additized a fuel is, or an oil is, sorry, it's more difficult to recycle. So we can get it to reasonably good levels. I've seen very good, group 2, group 3 style recycled lubricants, but it's kind of dependent on the source of those lubricants.
Correct. I think, again, I'll just add here, the problem is with the collection and segregation at source.
Mm-hmm.
If you look at the European and the Australian markets, most of the oil that is used is group 2 or group 3, because most vehicles are, synthetic oil based. Whereas in India, it's a mix. Unfortunately, when you're taking the oil out of a vehicle in India in a workshop, everything goes into the same pit. The hydraulic oil goes there, the engine oil goes there, transmission oil goes there. So obviously, you're not going to be able to get a good quality of, feedstock to be able to make a good quality end product. So there, the losses are very high. So here, the usability of the oil is much lesser as compared to, if I'm able to get a group 2 or a group 3 product in the same, as segregated, and then I can make a group 2, group 3 far more easier. And obviously, so in India, the estimate is 70%. Okay. So if I give you 100 liters of oil to a recycler, used oil, only 70 liters will come back as a finished re-refined base oil. Okay, that's the estimate. I think it's much higher, in Europe and America. So that 70% has to go up. That will happen only when your, the quality of 100 liters is much better, than what it is currently. Yeah.
Very much good.
Please allow me to introduce Mr. Anshuman Agarwal as well. He will be joining us as a panelist in place of Mr. Calphon for the discussion to be taken ahead. So allow me 2 minutes. He is joining us as a panelist. He is the MD and CEO of Minimac Systems. So by the time he joins, I will put forward the 4th question to take the discussion ahead. What are the main challenges and barriers faced in the reduction of carbon emissions, and what strategies or approaches can be employed to effectively address and overcome these obstacles? Over to you, panelists.
I'm happy to start. I mean, a lot of, in terms of the challenges, one of the biggest challenges I've probably seen internally within organizations is how do you quantify the benefit? Because let's say, for example, in our industry with lubricants, because we haven't had a standardized framework for what is the carbon intensity of a lubricant, let's say, for example, you save 100 liters of lubricant from going to waste. How do you then quantify the carbon emissions saved if there is no standardized framework for doing that? So up until now, it's been very difficult to put numbers to the savings. You can talk about liters saved, and you can talk about dollars saved in terms of not having to purchase new oil, but it's often been difficult to talk about carbon emissions saved. There have been a handful of attempts at doing it, but often when you go to management, they say, what are these numbers based on? And they wanted to see a standardized international framework, which, up until now hasn't really existed in our industry. So that's one of those areas where I think the API framework will really help. But the good thing I think about, and this is sort of a note of hope for everyone that's really associated with our industry, is that we have an opportunity to make very small changes that have very, very big and outside effects, right? So earlier on in this discussion, we talked about some of the individual changes that we can make at a consumer level. Well, even if you as an individual were able to eliminate most of the carbon involved in your day-to-day activity, you can probably realistically only get down to, let's say, 40% of the carbon emissions of an average person, right? So you're still having a net negative impact on the planet. The good thing in our industry is, even if you make a change to a mining company and that affects their carbon emissions by 0.5%, 0.4%, 0.3%, the net effect of that downstream is massive, to the point where you personally can claim credit for being carbon negative to the tunes of thousands of people. So a good example of this would be, just a quick case study. So, I worked with a mining company in New Zealand, and the only change that we made to their lubrication program was to go from using drums to bulk hydraulic oils. That's all. But when we calculated the amount of waste oil that's in the bottom of a drum, and you added it up over the thousands and thousands of drums that they used on a yearly basis, plus the carbon associated with manufacturing the steel of the drums, what we found was that it was equivalent to about 11,000 people's carbon emissions on an annual basis. So again, very, very small change to make, but outsized opportunity.
Sure. Thank you for your views. Please allow me a moment to introduce Mr. Anshuman Agarwal, who has joined us as a panelist. He is the MD and CEO of Minimac Systems. Welcome, sir.
Hi, hello. I was too impatient to join this panel, although I was not a part of the initial panel. But when I saw one of my friends going out on emergency, I thought, why should I miss the chance and be a part of this coveted panel? So please continue. I'll be happy to share my views as well.
Sure. Thank you so much, sir. We are on the question. I would repeat the question for you. What are the main challenges and barriers faced in the reduction of carbon emissions, and what strategies or approaches can be employed to effectively address and overcome these obstacles?
So I was hearing my co-panelists. I'm sure they have already given enough views on this question. So maybe we can proceed on the next question and have more and more involvement of the audience question, because I can see a lot of questions are still unanswered. So let's just proceed faster on the others as well, as we are losing on time.
Sure. So I would move on to the last question which I have for the day for the panelists. Do you have a case study or any relevant experience where you have witnessed or experienced an industry or a person taking a step, no matter how small, towards the reduction of CO2 emissions, and how do they or you personally overcame the challenges faced?
Yeah, so let me just put up a very relevant and important case study here. I think this is so one of my colleagues is a former UNDP head of UNDP circular economy here in India, and he heads one of the autonomous bodies called CEE, which falls under MOEFCC. So while in UNDP, when the plastic EPR came out in 2016, they implemented a huge project across 20 cities in the country, partnering with Coca-Cola India Foundation, HCCB, Hindustan Unilever, HDFC Bank, to essentially, for effective collection and recycling of plastic waste. And believe me, as I was saying earlier, it's making policy is one thing, but getting it implemented on the ground in a complex and unorganized sector like India. So I always look at the supply domain, what goes from the manufacturer to the consumer, as some it is what you see on stage, but the other side is always behind the scenes, right? And it's actually a very difficult place to operate. As this kind of small example or some small case study that I would like to cite. So these are little old numbers. I think India today generates more than 20 million tons of plastic waste, every year, and only 1/4 of this waste is actually recycled. Okay, due to lack of functioning solid waste management systems. Okay, so most of the plastic, as we know, gets into landfills or gets burned or gets into some waterways, gets into some municipal, discharge systems, sewage systems, and the like, right? So obviously, when the plastic EPR was rolled out, one of the objectives was, which the UN United Nations Development Program took upon itself, was to build on the existing systems of, as I said, there is already an informal system which exists to collect waste in India, right? The typical rack picker, way of collecting things and getting it to the, the kabadi walas, as we call them here, or the scrap dealers, as you call them here, right? So how do you build on those existing systems and promote the collection, segregation, and recycling of all kinds of plastic and move towards circular economy? As I mentioned, UNDP, Hindustan Coca-Cola Beverages, Hindustan Unilever, and Coca-Cola Foundation were involved in this, activity. And then this was actually a four-pronged model. It's, as I said, it's not as easy as it seems, because a lot of people who are at bottom of the pyramid are actually involved, and their education is zero. Their understanding of, what should I say, life expectancy is very poor. So basic things are missing, right? In where you want to implement these things. So the first and foremost, the team had to develop a socio-technical model where they have to identify local municipal wards, who would collect plastics from households, shops, hotels, schools, cities, places of worship, community halls, etc. At a very, very basic block level. Okay, imagine you are, kind of build the entire city, you are, getting gridding into, let's say, blocks of 1 kilometer by 1 kilometer, 1 square kilometer each. Then there are formation of resident welfare associations to spread awareness, engagements with the urban local bodies, with these pollution control boards and others, to conduct workshops on the technology induction and operation. Second, as a second step, they wanted to establish what we call, material recycling centers or facilities. So most people have, I don't know how many people have seen plastic recycling or collection or segregation facility, but this is one of the most important things that needs to be established. Obviously, you have to work with the local government bodies to agree on the space, agree on the location, rentals, all those things, and more importantly, work with suppliers. I mean, more than suppliers, work with the people who are actually going to use the entities are going to actually use the plastic that you have collected and recycled or reprocessed. So cement plants, local steel plants, the people who are into road construction, those kind of companies, right? So essentially you have to tie up with them. Otherwise, you collect plastic and what do you do with it? I don't know, right? So that is the second step in this, activity. Third step was, you wanted to, what should I say, institutionalize these material recovery centers. So you had to get on ground with the NGOs, with the, local self-help groups, and basically, provide a sort of training, education, awareness to these rack pickers, which technically we call as Swachhata Mitra. Swachhata is cleanliness, Mitra is a friend. So cleanliness friends, right? You provide them ID cards, you provide them, what should I say, insurance, and basically explain to them the importance of hygienic lifestyle, social security, and all of these things, right? And then you essentially go and, engage these rack pickers to ensure that they bring all the plastic that is collected into a central system, which is the Swachhata Kendra or the cleanliness, location. And the last but not the least, you need equipment, right? You need baling machines, you need, machines which shred the plastic, which kind of, maybe do other processing on the plastic. So all these things require money, right? And proper training. So you get that in place, right? So this entire activity, I think, ran over a period of, is still running, by the way. The data that I have, which my colleague shared with me, is basically in 3 years, 20 cities and 22 MRCs. You won't believe this project has collected, segregated, and processed more than 65,000 metric tons of plastic. And by the way, 1 metric ton of plastic is equal to 2.1 carbon emission, equivalent of carbon dioxide emissions, 2.1 kg of carbon dioxide emissions. So you can imagine what kind of carbon dioxide emission has been saved by, segregating, collecting, eventually recycling 65,000 metric tons of plastic just across 20 cities across this huge country. I mean, if this kind of project achieves scale, and if lot of more people, or many more organizations get into this project, you can imagine the kind of social impact and the kind of environmental impact that this will also have. Around 5,500 rack pickers became a part of this. Were picked up from the informal sector and brought to the formal sector. As I mentioned earlier, a big challenge in actually circular economy is actually getting the informal sector formalized, because circular economy exists, but it is not visible. Okay, it's invisible. It is behind the scenes. So how do you get them? How do you, for example, I mean, in oil industry, I know oil gets purchased. Okay, a mechanic makes money on oil, on selling used oil, but it's not on an invoice. Okay, we all of us know that, right? So how do you make that a formalized economy? How do you spread that awareness? That is, I think, very important. So this is not an easy journey, as this case study kind of shows. Okay, it's a tough journey, and there are thankfully a lot of committed people out there, who are willing to take the first steps and take the first. I mean, how should I put that machinery in motion, right? So I mean, for the first few years is going to be difficult, but as the benefits kind of start accruing, I'm sure more and more people will voluntarily start joining, and more organizations will come and support these kind of initiatives, right? So as a result of the initiative, UNDP was also felicitated by the Ministry of Housing and Urban Affairs, at the Swachh Sarvekshan Awards 2020 under Swachh Bharat Mission. So we all know that there is a Clean India mission which is ongoing for a very long time. Every year, certain cities in India get awarded, for being the cleanest city in the country, cleanest city in the state, ward, and all those things. So this will actually receive the award for the best delivery of the project. So this was actually served, I think, multiple purposes: cleanliness, arresting the carbon emissions, and as well as a social upliftment angle. And I think that's the beauty of this I think initiative. It's not just, I think, a climate change initiative, or arresting the climate change initiative, but has got multiple facets to it as well. So I'm, I think, very thankful to my ex-UNDP colleague who's kind of allowed me to present this case reference here. And yeah, I mean, as we go along, I think we are getting actively involved in the e-waste and used oil EPR implementation. I think Anshuman ji and Chetna ji were there in that conference 2 weeks back. So we also have to get to that level of implementation to be able to make this successful, right? I mean, we've always seen the formal sector, it's quite possible, but with the informal sector, it's a tough ask. Okay, there is so much involved, so much at stake for there. So yeah, that was a small case study, I think, with huge benefits. I think maybe Debashish or Rafa, you can add something, maybe Anshuman, in case you have something to present or talk about.
Yeah, that's great. And of course, even in the formal sector, that's the lubricants usage sector, we do understand that there are a lot of initiatives being taken towards enhancing the overall life cycle of a lubricant. So if I would like to speak specifically about this sector on how lubricated assets are being taken care of. So there has been a paradigm shift towards having better lubrication practices over the years. Of course, I have been into this industry for the last 20 years, and I have been seeing how the behavioral pattern of various industrial professionals, maintenance guys, and especially the lubricant specialists, how it is changing. And you'd be glad to know that the lubricant companies, the lubricant brands, now they are acting much more responsibly. 10 years, 15 years down the line, these statements of saving oil or oil conservation, they used to look or seem like more of hypocrisy if it used to come out from the mouth of a lubricant supplier. But right now, they are actually acting around all these initiatives. And as we have understood that EPR mandates all the lubricant suppliers to save the oil, to ensure that the oil which is being used over the life cycle, and once the life cycle is over, once the oil is defined as a waste oil, they need to ensure that that oil is circulated back into the economy, circulated back as a form of re-refined base oil stock, and being used as some percentage along with the virgin base stock. So these initiatives and of course the mandates by the legislatives, they are helping a lot. One of the few cases which we have encountered as we talked about the case studies. So there are of course dozens of cases which as a company at Minimac we have found out where lubricant replacement was avoided, because that lubricant replacement would have cost a huge amount of money for the asset owner. But those were avoided by best lubrication practices, by on-site lubricant treatment or in-service lubricant reconditioning, which we as a company, we call it as mid-life treatment or end-of-life treatment. So if we talk about the hierarchy of hazardous waste management, which says reduce, reuse, recycle. So we normally concentrate on reform or reduce the overall waste generation of any commodity or any product. So as a part of that, whenever the lubes are reconditioned during service, it would ensure that the lube would have an enhanced life, a better performance, and a longer duration when it can serve the basic purpose of lubrication. That would of course reduce the need, as Mr. Debashis pointed out, that there is 2:1 ratio in terms of lubricant replacement and the actual lubricant which is being circulated through the lubricated equipment or assets. It is 2:1 ratio currently prevalent in the market, but the benchmark should be 1:1. And this is what can happen if the lubricants usage can be enhanced, the life cycle can be extended, and the best lubrication reliability practices can be adopted. So you can take it as my conclusive comments also, because this is the end of the time slot that we had for this webinar.
Thank you, sir. Well said.
Yes, thank you so much, Anshuman.
Thank you, sir.
So, yeah, I have answered some questions on chat one-on-one. I think 14 of them. I didn't have the option to answer them for everyone, but I hope people who have asked those questions have got the satisfactory answers.
So we would take up some questions towards the end of the webinar. We will take up some important questions.
Sure.
So thank you so much for the insights. So that was a great discussion with our experts. Achieving net zero is a complex endeavor that demands not only technological advancements, but also significant changes in behavior and policies. It requires us to confront difficult questions about equity, social justice, and the fair distribution of the burden of action. If you want any details of our services and offerings, please contact us on the email ID mentioned here, and you can visit our website as well. Moving on to the AMA question, I would pick up some questions from the Q&A box since we are short of time. My first question to the panelist is, what's the difference between net zero and carbon neutrality? It is from the audience.
Maybe I'll take a stab at this one. My understanding of those two terms is probably that net zero is really referring more to like a global goal. So the entire world is trying to get to net zero. Carbon neutrality tends to be applied a little bit more on sort of like the individual or corporate level. So, a corporation can achieve carbon neutrality, but the entire world is going for net zero.
Yeah, carbon neutrality is a process. Carbon neutrality mainly refers to a process. Whereas net zero emission is to the across the country. You are adopting some process which is carbon neutral. That means carbon neutrality refers to a process, particular process. Can you hear me, Rafa? Yes, can you hear me?
Yeah,
yeah, okay. And net zero emission is in all aspects across the value chain. That's what I understand.
Do you think it also refers to the different scopes? Like net zero would talk about the scope 1 and scope 2 impacts, whereas carbon neutrality would cover up the entire comprehensive, even the scope 3 and the scope 4?
I'm not sure really. Let me give an example of carbon neutrality. Carbon dioxide with water is producing now propanol and methanol. That is a carbon neutral process. That is, I mean, these processes are coming out. Processes are coming out. They are still in the laboratory stage. They have to be done in the commercial stage also. That is carbon neutral. Now, if you say stage three is a very complex process. I cannot say it overlaps with scope. Sorry, scope 3 is a very complex process. It overlaps with scope 2. It overlaps with scope 1. I am not sure whether I'll be able to answer your question.
I think a lot of doubts are still remaining around scope 3 and also the upcoming scope 4, which would be a much more detailed, comprehensive inclusion of all the efforts around net zero and carbon neutrality. But to my knowledge, in a recent conference and a discussion, I could understand that net zero commitments majorly focus around scope 1 and scope 2 implementations. However, when we talk about scope 3, that would probably not be covered under the net zero commitments of various countries and companies. Because as you rightly mentioned, scope 3 is much more a complex topic and point of view. So in order to make things simpler and implementations non-conflicting, net zero talks majorly about scope 1 and scope 2 emission reductions.
I hope scope 4 will not be so complex.
It would be even more, of course, because it would be avoided emissions,
okay,
which did not even exist. So you talk about something which doesn't even exist, you talk about abating those things. So that's why scope 4 is still on a hold, because you're talking about imaginary concepts.
I think the policies, guidelines, and these concepts are moving at the pace of 10x of implementation, in my opinion. Because the real challenge is, I think, there, to be very honest.
But we should be glad enough that the traction is so strong and aggressive.
Very strong, very strong.
That we would certainly get onto certain targets as per the Paris Agreement.
Yes.
Maybe much before time.
Yes. I think that is the need of the hour.
I was thinking about the commitment made by our country in COP26 last year.
Yeah.
India is heavily dependent on power energy, conventional coal energy. So in the next 5 years, India will expand its coal energy by about 50%. At the same time, it will increase its non-renewable energy source by 20-30%.
Yeah.
So you can understand how challenging it is. How will you offset it? How will you offset it? Coal is most energy intensive. Carbon emission, carbon dioxide equivalent is huge. Carbon emission is huge, and at the same time you are trying to get the non-renewable energy sources like solar energy and hydrogen energy to reduce the carbon emission.
Of course, the technological shift for developing countries and countries who have just developed, like India, it would always be challenging to invest heavily onto the innovative technologies. But however, what we see right now is some of the drives in certain countries has been tremendously aggressive because of the commitments. And as you rightly mentioned, yes, the capacity addition in terms of nuclear power and solar power or non-conventional sources has been tremendously high in countries like India. But as a matter of fact, if you have to run the industry, if you have to run the domestic requirements, of course, the conventional sources also become important, and that would continue to grow at a lower pace, of course. So the commitments made by the country, commitments made by the industries would be fulfilled much ahead of time, that we are of course sure of, but we can't avoid it, or we can't do a blunt stop of it. In fact, we saw certain turmoils happening in other countries, even the developed nations, wherein all of a sudden the conventional sources of energy were unplugged, and they actually created some sort of turmoil, chaos in the energy supplies. So that's the reason why for countries like India, there would be a very cautious methodology which needs to be followed, which we are seeing, of course, happening in a similar fashion.
True, very true.
Thank you, sir.
Sure. Thank you for your views, sir. Moving on to the next question by Dr. Tina, which is in the chat box. What innovation governance strategy of the decarbonization after the UN Decade Program 21 to 2030 and after 2030 to 2050? Should I repeat the question?
Yeah.
What innovation governance strategy of the decarbonization after the UN Decade Program 21-2030 and after 2030-2050?
So what I know about is a lot of companies today are working around decarbonization of various activities, and we talk about verticals which are completely virgin verticals known as sectoral decarbonization. So companies like Shell, British Petroleum and many others today have formed virgin verticals in their corporates, which would be working around sectoral decarbonization, which means they would be helping various other industries across the sectors to figure out ways, innovative methodologies and technologies which would help their processes, products and its usages to be decarbonized. For example, if I talk about the lubricant sector where we belong to, so the entire life cycle of the lubricant needs to be decarbonized, not just the source of lubricant, but the entire life cycle. As a matter of fact, a lot of other practices, procedures, methods, everything has to be changed. The behavior of the users of lubricants have to change. The way how the organizations today treat lubricant, probably a lot of organizations treat lubricant as a consumable, and that's the reason why we have a 2:1 ratio for lubricant manufacturing or lubricant usage versus lubricant in circulation. So once these behavioral patterns change, of course, these would be certain vectors towards decarbonization efforts. And this is not just for this one sector, but of course, for the entire sector of the industry. So as I'm belonging to this sector, so I spoke a little more about that.
So my last question from the audience panel would be, how can individuals reduce their carbon emissions? And what impact can individual actions have on the overall problem of climate change?
The first thing we can do is we can switch off the air con if it is not hot outside.
Kedar has just mentioned this.
You can, I know you can see this book, The Low Carbon Lifestyles, released by the Ministry of Environment, Forest and Climate Change. If I'm able to lay hands on this, Anshuman and Chetna, I will send this to you. It's a very top class booklet, talks about how much carbon you can, or how much energy you can save, right from doing small things at home. As I mentioned, just plugging out the plug point, drying your clothes in the sun, okay, use a cold cycle in the washing machine. I mean, this is just amazing. And I didn't know that this, I mean, just a month ago that this book had been released, and I'm actually going through it and I just read it. I'm amazed, Do not waste food, walk if you need, do not drive, all of that. Regularly inflate vehicle tires, okay, change flush tanks in the bathrooms and whatnot. I mean, they've just given a complete calculation of how much would you save, okay. I don't know if you can just have a glimpse of it. It's not readable, but yeah. There's a CD as well. Maybe I can send it to you.
So what we could do is, if the buy link of this particular booklet is available, then we could share with all our viewers.
Sure. This is brilliant.
Yeah, as a follow-up to this webinar, participants, we can certainly do that.
Yes, absolutely. And actually, actually what happens is, we all say charity begins at home. So if you do it at home, you'll obviously do it in the office and in the factory, okay. And, and somewhere else, right? I mean, so for example, I mean, I always have this Japanese example, they do this lean manufacturing or Kaizen or whatever. It is nothing. It is what they do in the household, they do it in the factories. Okay, it is very simple concept. Okay, if you can do it at home, why can't you do that at your workplace or vice versa? I mean, unfortunately, we have good habits at home and probably bad habits in the office or vice versa. But so I mean, it's simple. I mean, each one of us can contribute. But as Rafa mentioned, it's the bigger contributors to, I think, the carbonization are the industries, and agriculture and energy generation and steel plants. But yeah, in our own small way, we can definitely, make a difference, right?
Clarification from the panelists, from Suman sir and Kedar, and if I want some clarification from you. When I switch on the AC, window AC or split AC, what will happen if the ceiling fan is on? Is the question clear?
Yeah.
If the AC is running and the ceiling fan is also simultaneously running, is it good or bad? I'm asking this question because ceiling fan is delivering hot air. The AC is delivering cold air. So extra air the ceiling fan is delivering is to be cooled by the AC. So AC has some extra load, and this on-off system will not work if simultaneously the AC and the fan is on, ceiling fan is on. I want your views on this. I have searched in the net, but I have not got in the net.
I believe most of the rooms which have an air conditioner, they don't have a ceiling fan. At least in other countries, this is what we have observed. However, in India, because of certain low voltage issues in certain cities and parts of the country, probably both ceiling fan as well as air conditioner are being used. So technically, understandably, of course, you use one device for one purpose. So either you use a ceiling fan or you use the air conditioner. So there's no logic point behind using both of them together.
Right. Now in India, as you said, it gives the climate also, right? I mean, you need the AC in the summers.
Yeah.
But in the winters, you're in the same room, you don't need the AC. So you
right. So if you
fan. That's the purpose here. But yeah, I mean, you're absolutely right. You need, I mean, practically you want them both, but you don't need them both.
At the same time, simultaneously, right?
Yes. You want them, but you don't need them both at the same time. So
because you see, the AC is delivering cold air, the fan is delivering hot air. AC is not designed for that hot air, so the AC's cut-off system will not work. It will have an extra load.
Yeah.
Always. Yeah. I mean, that is the best practice. That is one of the practices we often use. That is not a good practice.
So we have to go back with some food for thought and some homework which Dr. Mukherjee has given us. Figure out what is better. Great.
Okay. So do we have any more questions, Chetna?
No, sir. I think we can wind up. Please allow me the same. So thank you so much, sir, for your views. The momentum for change is undeniable. Governments, businesses, and individuals are increasingly recognizing the importance of aligning their actions with the imperative of net zero. From the United Nations Sustainable Development Goals to corporate sustainability commitments, the global community is forging ahead on a path that leads to a sustainable, prosperous, and equitable future. Once again, I extend my sincere gratitude to each and every one of you for joining us. I would take this opportunity to introduce Minimac's first ever publication under the name of Mintonia, a publication which aims to empower and embark on a journey full of insights, the first edition of which would be released in the coming month. Stay tuned. If you want a free copy of the magazine, please write to us at info@Mintonia. It's there in the chat box. My sincere gratitude for our esteemed panelists for joining us this afternoon and giving us such meaningful insights. Your presence here today signifies your commitment to the cause, and your collective expertise, I'm sure, has helped the audience a lot. Let us embark on this enlightening journey towards net zero, fostering an inclusive and meaningful dialogue that sparks actionable solutions and propels us towards a future of sustainability. Your feedback matters. Please fill the survey form. See you next time. Thank you so much.
Thank you so much.
Thank you so much.
Thanks, everyone.
It was a pleasure. Thank you.